Okay, open your books to page 161 and we're going to look at a couple of proofs in this section. Again, I know we're skipping around a little bit, but we're trying to look at as many different types of proofs as we can so that we're more familiar with what's going on. Okay, so again, we're still doing our two-column proofs where we have our statements on the left and then we give our reason on the right. You cannot make a statement unless you have a reason for making it. Your reason is just your explanation of why something is true. Okay, so we want to consider the following diagram here. And we're given that segment OS is parallel to segment HE. And they want us to prove that OH over OR is equal to SE over RS. So we want to complete the following proof to go from here to here. So the first statement is that OS is parallel to HE. Usually our first statement and our first reason are almost always the same. We write down exactly what we're given and the reason for that is given. It's the easiest one. Okay. Next we have that the angle ROS is congruent to angle H. So ROS, so that's this angle here, is congruent to angle H. Well, why would this be? So let's look at it if we extended these parallel lines, and then we have this transversal here of H to R. Oh, well those would be corresponding angles. Okay, what about RSO? RSO, so that's here, would be congruent to E by the same thing. They're both corresponding angles, just here's with a different transversal. It's a transversal RE. So let's erase all of our extended lines and just label the angles. So ROS, an angle H, and RSO, an angle E. Okay, so we have two angles that are similar or congruent, so that means what? Well, it would mean that our two triangles are similar because we have the angle-angle similarity criterion. So triangle ORS is going to be similar to triangle HRE. Okay, well what do we know when we have similar triangles? Well, their sides are going to be proportional. So HR over OR is proportional to RE over RS. What is this by? Well, this is by proportional, this is by similarity, rule of proportion. Okay, but we can break apart HR. So HR is this full segment. We could break it into two sections, HO plus OR. Okay, so we just split it up, H to O and then O to R. Similarly with R to E, well we can split it up with RS and then SE. And this is just by our segment addition postulate. Then we can break apart our fractions. We get OR over OR plus HO over OR plus RS over RS plus SE over RS. And this is by the fraction addition. Okay, then let's simplify our fractions. Well, OR divided by OR will simplify to a 1. Same thing with RS. So this will be by substitution. Okay, we just simplified. And then what would our last step be? Well, our last step is by the subtraction property of equality. So subtracting 1 from both sides, we get that HO over RO is equal to SE over RS, which is exactly what we wanted to prove, so we're done. Just a quick note on proofs in general. The first statement is what you are given, and the first reason is the word given. Your last statement should be what you are trying to prove. If it is not, you did something wrong. Not necessarily wrong in that you can't correct it, but wrong in that there's a certain number of steps and you should have been able to get to that final step by the last blank that's given. Okay, so on the practice problems, be sure that you always end with what you're trying to prove and you always start with what you're given. Okay, it's kind of like here's the board game where here's the start and then here's the end goal. Now let's flip over to 162 and we're going to look at a proof there that also has to do with similar triangles. So we'll just slide it over to where you can see that. Okay, so it says consider the diagram to the right. And we're given that the line WI is parallel to SG. And we want to prove that WN compared to NG is equal to WI compared to SG. So what is our first statement? Always going to be our given. Okay, if you haven't got that yet, make sure you drill that into your head. So our first statement is what we are given. Well, we're given that WI is parallel to SG. Okay, then our next statement that we need to figure out what the reason is. It says that angle WNI, so that's here, is congruent to GNS. Well, why would those two angles be congruent? What type of angles are those? They're vertical angles. Okay. Then next, we want to find a pair of angles that are alternate interior angles. Alternate interior angles. Remember alternate interior angles. We have two parallel lines. I know those do not look parallel. Let's try that again. Two parallel lines cut by a transversal. Which one are going to be our alternate interior? Well, something like this. Okay. So let's see. Do we find a pair of alternate interior angles? Or it could even be this set too. So looking at our transversal along here, we see this angle. What would be its alternate interior angle? Well, it would be this one. So we have that angle I is congruent to angle S. Or you may have seen that angle W is congruent to angle G. Either one would have worked. Either one would be sufficient. So now that we have two angles that are congruent, then we have that the triangles are similar by the angle-angle similarity criterion. So we have that triangle WIN is similar to triangle GSN. Okay, what do we know about similar triangles? Well, their corresponding sides are going to be proportional. So how would we get that WN is proportional to NG? Well, it would be because corresponding sides of similar triangles are proportional. And that would be the last step of that proof.